Subclass Mr. Wickelhouse, and today we are solving matrix equations. Alright. This isn't too bad, but it'll get more complicated as we go. So if I know that I have two matrices that are equal to each other, then I also know that all of their elements must be equal. So if I have this matrix and I say that it's equal to this, then each spot in its elements, so A, corresponds to the 2. So I know that A equals 2. And B corresponds to the 3. So I know that B equals 3. And so on. C equals -1. And D equals 4. Okay. So that's not real hard. Let's make it a little bit different here. I've got this matrix, and I say that that's equal to this matrix. Well, I'm trying to figure out what X and Y are equal to. So all I'm going to do is look for the spot where this matches up to the element over here, which is -2. So I can say that X equals -2. From the same standpoint, I've got the Y here. I'm looking at the element that corresponds to that, which is here. So I can say that Y equals 0. Okay. Let's take it up another level. So now I've got this matrix is equal to this matrix. When you've got these things going on in between stuff, like this X plus 2, that is still the first element in this matrix. Don't think that this is one element and this is another. These two things are together on this one. So then this corresponds to this. So I could say that X plus 2 equals -4, which means then that I'm going to subtract 2 from both sides, and I get X equal to -6. Okay. Now I've got this one, and that corresponds to the 2. So I do Y minus 1 equals 2, add 1, and I get Y equal to 3. So those are some examples of the elemental equations where I can just take elements and set them equal to one another. Now then, moving forward. Alright. You might have some equations that look like this, where I'm saying I've got a matrix and I'm adding another matrix to that matrix, and then it's going to be equal to this. Okay? Well, you want to think about this matrix just like it was any other number. Oh, we went out of focus. Hold on. You want to think about this matrix. Is it going to stay there? Okay. You want to think about this matrix as any other, like you would be solving any other equation. So like for instance, if this was X plus 1 equals 3, then you would subtract 1 from both sides and get X equals 2. Well, when we're working with matrix equations, I'm basically going to do the same thing. Except now I'm going to be subtracting a matrix from both sides. So I'm minusing 3 over 1 from both sides. Just like that. Okay. We know from earlier in this unit that how to subtract matrices. I just subtract the elements. So 4 minus 3, that's 1. Negative 2 minus 1 is negative 3. So then I get 1 over, and negative 3, that's what matrix A is. Okay, that's not too bad. Subtraction, that's going to be the same way, except now I'm going to be adding the matrix 3, negative 3, 0 to both sides. That's 3, negative 3, 0. So we'll be adding elements together. Negative 2 plus 3. That is going to be 1. 4 plus negative 3 is going to be 1. Negative 1 plus 0 is negative 1. And that's what is equal to B. Okay. Alright. Now I've got this one. I've got 2 times the matrix D, and I'm saying that that is equal to this. This is where it's a little bit tricky because it's not as easy to think about as just dividing by 2. I don't want to think about it that way because I can't really divide numbers into a matrix per se. Myself, I think about this as, which is really the same, dividing by 2 or multiplying by a half is the same thing. So I'm thinking about multiplying this matrix by the scalar 1/2. So I'll bring this 1/2 into the matrix onto every particular element. So 1/2 times 2 is 1, 1/2 times 4 is 2, 1/2 times 6 is 3, 1/2 times 8 is 4, 1/2 times negative 4 is negative 2, 1/2 times negative 2 is negative 1. There's my matrix, and that is what is equal to D. Okay. Alright. Moving forward, this will be the last thing. So you remember earlier we learned about finding inverses of square matrices. Well, this is the same idea here. And I'm going to use these inverses finally to actually do something. Okay? So I've got matrix A and I've got matrix B. And then I say matrix C times matrix A is equal to B, and I need to figure out what matrix C is. Okay? Well, I'm going to plug all my matrices in that I know, and after I get those plugged in, then I'm going to be able to solve for C. And the way that I do that is I multiply by the inverse. Essentially, multiplying by the inverse is going to cancel out this matrix A, so I'm going to multiply by the inverse of matrix A to get the C by itself. I can't just divide by matrices. It doesn't work out that way. The inverse is quite similar to dividing when we're talking about matrices. So that's what I'm going to do. So I've got C times A times A inverse is equal to B times A inverse. We've got C times A inverse is equal to B times A inverse. Okay. Alright. So, to do that, I'm going to jump to my handy dandy calculator because it's going to make that super easy to do. Alright. So I need to get my matrices entered in. Alright, so if you remember, second matrix, go over to edit, we'll go to A, and that's a 2 by 2 matrix, and the numbers in that are 3, -2, 0, 4. Alright, now we'll go back and go to edit again and go to B and get that one entered in. So it's a 2 by 2 matrix, 2, -3, 1, 2. Alright, now I'm going to be entering these numbers in. And really all I have to do now, I just have to do this side of my equation. So I'm going to take matrix B and multiply it by A inverse. Alright, so I'm going to go back into matrix, and now I'm going to go and hit B. So now I've got matrix B, and I'm going to go back into matrix and multiply that by A, but then I'm going to hit this inverse button, which is going to take the inverse of A for me. Then I'm going to hit enter. Alright. Well, now that I've done that, I can see a whole mess of things here. Okay. And what I end up with, this is not these, but instead that is equal to 2/3, 1/3, this is 2/3, and hold on 1 second and I'll give you the last one. The last one is going to be -5/12. Alright. Sorry about that little lag there at the end. I had to recalculate these things. Alright, so I will talk to you later. That's how we do all of our matrix equation solving. See you later.